Welcome. I'm Vijay Kumar, the Nemirosvky Family Dean of Penn Engineering. I'm here today with three individuals who have helped build the foundations of AI at Penn Engineering. Dr. Raj Singh is a pioneer in cellular communications. The algorithms he wrote, along with his wife, Dr. Neera Singh, in the late 1970s and early 1980s, helped companies establish cellular networks all over the world. At Penn Engineering, they have likewise made a substantial impact. First, by supporting the undergraduate program in network and social systems engineering, and now the first Ivy League Bachelor of Science in Engineering in Artificial Intelligence. Harlan Stone is, simply put, one of the most visionary and enthusiastic supporters, not just of Penn Engineering, but of Penn as well. His passion on the intersection of arts and humanities with engineering and data science has led to the creation of the soon-to-be-opened Amy Gutmann Hall, which will serve as the interdisciplinary hub for data science across the university. A leader in sustainable manufacturing of decorative building materials, Stone is also a proud member of a multi-generational Penn family. The story of Fred Warren is the story of interdisciplinary learning at Penn Engineering. His career has leveraged his engineering training in the context of business, and his philanthropy has underwritten research at the Warren Center for Network and Data Sciences. It supports research at the intersection of technology and society. Welcome to the show.
Thank you.
Thank you.
So let me start with my first question, and Raj, perhaps you can answer this first. How you've been involved in AI and data science, and at what point in your life, in your career, did you think that this field was going to be as important as it's become today?
Well, the beauty of history is that everybody knows history after it happens. But it's very hard for people to kind of predict that what is coming out in the future, the unknowns. So my background goes back to 40 years ago when wireless industry started. Nobody thought that we're going to have more than 2% of population would have cell phones. Now, 2% was the best case scenario. Now we have basically 100% penetration. So being a PhD in electrical engineering and wireless and radio spectrum, I have always kept interest in learning about new things, whatever they are. So we have been following in our companies machine learning and computer science and algorithms, which is how I actually built our original business. We have been following it for a while. And I think a few years ago, basically AI conversation has been around for a long time, but about 4 or 5 years ago, when new things started coming and large language models came around, and there was a lot of conversation we kept tracking. Still, like one of our cybersecurity companies still uses machine learning, but look, it's a progression of things. And then we took interest, and just about a year and a half, 2 years ago, when ChatGPT and all the other systems started coming out, it became quite clear to me that as far as artificial intelligence is concerned, it's not going to be limited to certain set of specific application, but it's going to have a more general use, and it can be almost applied to anything. So I would say the knowledge is recent, but realization is deep.
That's excellent response. I love the comment about history. Harlan, same question to you. So I know you've been a big advocate of data science on Penn campus, but I wonder when you first got interested in this field.
I want to touch on something that Raj said, which was curiosity. So curiosity is what I learned as an undergraduate here at Penn, is to be curious and to keep looking deeper. I was interested in some aspects of computer graphics as an undergraduate here in the 1970s. I then lost touch with it and started my career. But when I read about Penn's computer graphics undergraduate program, the triple major between communications, fine arts, and computer science, digital media design. I said, wow, this is turning into something that really happens. So I came back to the campus, and at that time I said, so how far can we take this? And that's when I thought maybe the intersection of the humanities and data science can really be something like a new renaissance, which was actually my undergraduate studies. I said, wow, this is the technology and the art that can come together again to revive us and make the nation, the sense of humanity stronger. So as I first thought about investing with Penn in data science, it was a very small view. But as I learned more about it, as you became dean, Vijay, I said data science is much bigger than I thought. So I would trace my elevation to the time that you became dean and described data science as the new liberal arts.
I love it. But if I can press you a little bit further, I know thanks to you, I learned a lot about how data science can play a role in art history, help art historians, and even the naive museum goers like me better understand sort of the history of art. I wonder if you could say a little bit about that.
So one of the proudest moments in this journey for me, and it's a continuous journey and continuous curiosity, was when I got Costas to get together with an art history professor and teach a graduate course in art history and computer vision. His computer vision knowledge came from the GRASP lab and from robotics. And the art history professor was interested in learning more about gestures. So they were able to get half master's students in computer vision, mostly robotics, and half art history students. So we're studying Renaissance and Baroque painting and study the gestures of hands, as I'm using my hands here, to try to understand where were the similarities, where were the differences. And they came up with an astounding number of observations that would not have been made easily without someone being a connoisseur of the highest order. So suddenly it became a democratization and an expansion of this field. And I was, one of my proudest moments was sitting in on their class when they did kind of their discovery analysis. So that was the beginning of it, when I realized this is something that can go in an unlimited way. And as Raj referred to, we can't think of it in a limited way. Our goal should be to think of artificial intelligence and big data applying to social sciences, as Fred wants to do, to optimization of networks, as undoubtedly Raj wants to do, but also to help the humanities and be informed by the humanities and by even other things like law, nursing, medicine, to help this become a tool for the betterment of humankind.
Awesome. So we've talked about networks, we've talked about data science, a perfect segue to talk to Fred Warren about data science and networks. Fred, what got you interested in this field?
Going back to my degrees, my dual degrees in engineering and finance at Penn, led me to become a venture capitalist. And at an early stage when people didn't really know what venture capital was, neither did I in the beginning, but I was a fairly fast study and learned a lot very quickly. But along the way, I started my own firm called Brentwood Associates back in 1972. And in about the mid-'80s, we made an investment in an artificial intelligence software company called Lisp. And that was one of the languages of artificial software back in the early days of that subject matter. However, there were no applications that were present or even visualized at that time. It was more, here's a subject of artificial intelligence. We should learn more about that and learn how to use it. So it remained somewhat dormant as a subject matter until the last few years. But over the last few years, we started making a number of investments, early stage investments in analytics and various decision-making support companies. And then it started, the idea of artificial intelligence came back into fore, and people started talking about how do you take that data analytics and make it more productive? How do you personalize the targets or the solutions that come out of that? And so then the last year or so, it has become a more universal topic by the public and others. And I think one of the best examples I've heard described to this subject is at a dinner party last fall in Newport, Rhode Island. I met the founder of Ubisoft, which is a gaming company, and we started talking about the new subject of artificial intelligence. And I said, well, what are you guys thinking about how this is going to impact gaming? And he said, well, around our firm, we think that the next 100 years of progress are going to happen in 10 years because this is such a transformational subject that it's going to create enormous consequences very rapidly. And guess what? That's what we're experiencing today. So we're making investments to take advantage of that. Many of the companies we have investments in are already starting to adopt this in their ways.
Something you said, I want to go back to that. I think you combined engineering and business training at a time when we did not have the management and technology program, the Jerome T. Fisher program. I just wonder how you converged on that early on in your life, and what impact do you think that has had on you?
That's an interesting question, and it goes back to my freshman year as an engineering student. I went down to visit with the dean of the engineering school, whose last name was Warren, by the way.
Reed Warren.
Reed Warren. He wasn't a relative, but I never disabused my classmates of that. And I said to Dean Warren, I said, you know, I look around my classmates and in these classes, and I fear that they are much more serious engineers than I am. And I think that really I want to someday be a businessman, but I really don't want to give up my engineering degree because I think it's a great problem-solving mentality, and it really helps me with analysis and things like that. So do you think there's any way that I could dually matriculate in the Wharton School and get 2 degrees when I finish? He said, well, let's find out. He said, get your hat and coat and let's go down the street to the Wharton School. So we did, and we met with the dean of the Wharton School. In 1 hour, those 2 deans put together what became the M&T program, because they sat there and traded off, well, you can get credit for this engineering school and the business school guys give me credit, and back and forth. And so here's what we'll end up with. At the end of 4 years, you get your engineering degree, and you spend a full year, full-time in the Wharton School, and you'll get a master's in business at the end of that 5th year. So that's the deal. So that's how it happened.
Arguably the best investment you've made.
And for the university.
University and for
well, I mean, it's just been an incredible, and they didn't do it right away. They said, we have to study this and make sure that, and they did modify it a little bit after that.
So continuing on this theme of investments, Harlan, you have been in the sustainable manufacturing business. And I wonder how you think about that as an investment. And of course, you know, your career has been dedicated to that, to developing businesses.
Although I'm not an engineer, I believe deeply in engineering. As Fred said, it's a way to think. And I think over my exposure, I've learned to think like an engineer. My business is very much based on polymers. So understanding how to use them, how they're created, what's their life cycle, what happens at the end. This is something that has been on our minds for a while. And thanks, again, I will say to Fred, in his innovative way, he introduced me to the Huntsman family. John Huntsman was a classmate of his, and I approached Huntsman Corporation, and Peter Huntsman is the CEO there, and they helped me to design a new polymer that we can use waste from the ocean waste, single-use plastics, recycle it, upcycle it, not recycle it, upcycle it into a highly sustainable, superior performing polymer that we can then grind down and use again and again and again. And from there, we then thought about maybe not doing that, but just repurposing it at the end of its life, taking it and giving it a new coat. So you think about these things creatively enough. You think like an engineer, and as Fred was talking about his invention of the M&T degree, or Raj's inventions of cellular networks and then the AI degrees, I think of something that you taught me that became one of our company's signature quotes, which is, if you want to know the future, just invent it, which is attributed to Abraham Lincoln. So from 1860 to Fred's invention to yours, and then you mentioned that to me, and we live by this. So, if something is made this way, but it could be made that way, and it increases the sustainability, it's good for the planet, it's good for my business, and it's good for the consumers at the end of the day. And this is something that we're in the midst of launching this year. So about 5 years in the making, and that's been really fun.
Raj, if I can ask you a little bit about the results of your investment. So your comment about wireless networks and cellular networks reminded me of what T.J. Watson said about the number of computers that he predicted the world would need. I think the number was 6. And of course, today it's impossible to imagine humanity without cellular networks, right? But you've been in the front row, have a front seat to the development of all of these technologies. But again, as you think about this, what experiences have you gotten from that development? And I see that AI is in a similar trajectory. Obviously, cellular networks shaped us as a society. How do you see AI shaping us as a society?
So it's kind of like a very interesting quotation and paraphrasing, I think, from historian Paul Johnson, that history is a great teacher. But we all also realize that history can't be a scout. We have to scout ourselves. So in that context, if you go back to cellular technology, cellular licenses were granted in early 80s. Technology have been talked about and concepts have been around for a long time. And then once the licenses were granted, first cellular system was in like 1982-83, was in Chicago. Second one, I was involved in the Washington, D.C. Cellular One, was in 83, around that time. And none of us could have predicted what this thing would look like. The reason being is very simple. Our brains are trained to see things, and this is like Daniel Goleman, who is a behavioral economist. Like what he says is, what we see is all it is. And that's how our brains are trained. So in 1982-83, I was the technical advisor, get called to these boards, and they say, well, we have a business plan, here's an investment thesis. Everybody talks about 1% penetration, 2% is top. The reason being is, for things to happen, you have enabling technologies to come together, not just the concept. And so 3 things have to happen: human and financial resources, enabling technologies, and then underlying engineering and physical principles. All those 3 things have to come together. Now, think about the scale of enabling technologies. If you think about in 1982-83 timeframe, a bandwidth of a channel was 30 kilohertz. Right now, we're talking about 100 megahertz, like 30,000 times. Okay. If we're talking about number of cell sites in the country when the systems started, probably about 1 to 2,000. Right now, we have 500,000 cell sites, not even counting in building cell sites, just the outdoor cell sites. Okay? Think about the memory. The storage memory was about 30 megabytes. Today, we're talking about 1 trillion megabytes in memory, 1 million times more. So I think what happens is, as these enabling technologies come together, the functionality of the concepts becomes more ubiquitous, becomes more affordable, becomes more general, and the whole thing changes. I think AI will follow the same path. So I want people to imagine a world where, think about AI, a large language model, which is, let's say, is 1,000 times faster to compute, 1,000 times more to have inference drawn from the large language model. Think about that you have memory not only 1 terabyte, but to have 10 terabyte. So entire knowledge is right in your edge of the system or in your cell phone or your device. when these enabling technologies come, I believe that what we are thinking about artificial intelligence would not look like anything what we see today. It would be something totally different. I can't tell you what it would be, but if my guess is from learning from history as a teacher, it probably will be much grander and much bigger than what we can imagine.
Indeed.
May I just add another example to what he was saying about the changes that have occurred over these periods of time? In 1978, I was meeting with Steve Jobs. At the time, he was raising his first major round of financing. And he made the comment in the presentation that one day every man, woman, and child was going to own have a computer. And I said, hang on a minute, Steve. The ENIAC is the first computer. I went to Penn. The ENIAC is in Penn, and it occupies a room about 2 stories high and about 40 or 50 feet square. And it takes 100 engineers to keep it going and to software program it. So how are you going to have every man, woman, and child have a computer? And he said, well, we'll take care of all the user interfaces. We will make all the software implied in the machine, and all they need to do is just operate according to some simple instructions. And one day they will all have one. Well, here we are. This is it. So much to your point, it takes all these different changes in technology to make that possible, to go from that room down below to this device here. So it's a point well taken.
So I want to come back to AI and Penn Engineering, and I have a 2-part question about your investments in the school. And Fred, I'll start with you first because you made the first research investments, and then maybe chronologically, Harlan, you invested in the infrastructure that allowed us to recruit faculty. And Raj, you're now investing in the new educational program, so maybe we can go in that route. The question I have for you, it's sort of a 2-part question. Why do you think Penn Engineering can have the impact that it needs to have when it comes to AI? And why now? Why did you decide to make that investment now?
Well, I think that the fundamental and underlying technology that's present at Penn surely suggests to me that this is the ideal subject matter for Penn Engineering to take on. And I have to give Raj a huge amount of credit by his willing to step up and make that bet.
Well, I have to give credit to Vijay to come up with the idea.
But I also say that Raj also came up with the idea of the NETS program that basically caused me to make my first major investment, which was in the Warren Center, because it was really a takeoff on what he was doing at the undergraduate level. We did at the graduate level in creating that entity. So it was clear to me that Penn has the capability to innovate and be a leader in the forefront of these different engineering, science, and technology developments. And it was just natural that Raj would pick on that and support it by that new AI degree that's been introduced, and I applaud that greatly. Penn deserves it.
Thank you.
And they're the first.
Indeed.
Thank you.
We're pioneers.
Thank you.
Yes.
Thank you. Thank you.
We'll come to Raj soon, but first I want to ask you, Harlan. So again, I mean, obviously we're very grateful that you decided to invest in a building for data science, a new home for AI, but what made you think of that as the next big thing for us?
So, like any idea, it's built on the ideas that I saw before me. I talked about the digital media design program, which brought me back to the university and brought me to become involved in engineering, which I was not involved in as an undergraduate, other than one summer school course. But then I saw programs like the Warren Center, where suddenly you're using computing to cross a different discipline, and you're crossing out of science and engineering into social science, which is more close to my interest and my heart. And then I'm thinking, is it really true that I could make an investment. At first, it was a small investment to just have a center. Well, I was talking to Eduardo, and it was okay, a center where the humanities or visual perception and data science could meet. But then I started thinking more and more about the impact. So social science brought me to impact. And what Raj is describing in terms of technology is going to be the big influencing factor for how the future goes. So I kept thinking, actually, it's not about data science helping the humanities. I got this moment where the light bulb went off, where it was the humanities and the liberal arts helping big data and engineering to imagine a world in which we use this incredibly empowering technology to actually do good. Or as Ben Franklin would say, using your curiosity, all things, ornate and practical, to be used for the good of the mankind, good of the citizens of this city, good of the citizens of this state, this country, and the world. So suddenly I thought about how technology needs to adapt some of the greater principles that we as human beings have been able to discover. History is one, tragedy, law, ethics, medicine, all these things suddenly become part of the social fabric to which the technology should be attached so that it can serve. And that made me want to give as much money as I could possibly scrape up. And of course, I come from the built environment. I support buildings. I've built a lot of buildings. And I said, so what's my role? And I said, let's take a line out of the movie and say, build it and they will come. So when we built the building, we had no idea what was going to go into it. And today we've got an AI undergraduate degree in it. We've got the medical school taking a whole floor. We're inducing the law school to come across the intersection. So amazing things happen when you build it. And of course, this becomes a place where a lot of unforeseen intersections will take place. And that's the magic of what we can't see. We can only know what we see, but sometimes you can maybe imagine the world can be better than it is. And I'm a pathological optimist, so I see technology always as service to mankind, and therefore this building and this investment I made hopefully will bring that about.
Terrific. And I should say we've been inspired by your commitment to sustainability when we thought about this building. And of course, it is a mass timber construction, which is, from an energy consumption standpoint, embodied carbon standpoint, is vastly superior to steel and concrete buildings. So thank you for your commitment. So Raj, the undergraduate program. So this is the first undergraduate program of its kind in engineering, housed in an engineering school. What made you think that this was something you needed to invest in?
Well, I think the reasons are multifold, multidimensional. But let me start from one and then get to the next one. The number one is that in entire human history, unless you don't have democratization of knowledge or some idea, it never really probably not going to turn out very well for mankind. We have lots of examples there. So I think undergraduate education in any new idea or on any new technology or any new concepts is one of the most wonderful things, because these are the people then go out, spread around that knowledge to the entire society, and therefore society can benefit in general. So undergraduate education is the one most important reason. But that's not the only reason. The other reason is the beauty of history is it's always on life's edge. It's never 90-10. It's always 49-51. Any concept, any idea, any technology can be used for good or could be used for bad. And you hope that in a setting like University of Pennsylvania, Penn, where you have people who think about world in general, think about ethics, thinks about law, thinks about humanity, that they would steer it more in the direction of 51 good being for mankind. There will still be bad. You can't avoid that with any innovation in technology, but you can steer in the right direction, which is for the betterment of the human society. And third one is, it's just the wonders of how widely this can be applied. Think about what humans would be if we didn't have a language. Language is a common thing which we can all share. Now, to me, eventually AI would become the next layer of human language where machine and human, where machines can learn from each other and humans can learn from machine and machine can learn from human. So it's just another language. And therefore, the power of language and the power of the concept can be so general. We don't know what the ending is going to be. People talk about self-awareness of artificial intelligence and all that. We don't know what would it be, but I think the young minds have to be focused on that. So I think there is a multitude of reasons why undergraduate education in artificial intelligence, and especially a place like here where you have all the ingredients to quickly start it. And thank you for your speediness because you guys brought it all together. So I think there is a multitude of reasons why AI, why undergraduate education AI, and why Penn.
So you talked a lot about history and what we can learn from it. Now I want you to predict the future. So imagine you have students coming in, enrolling in 2025, the class of 2029. Where do you think we would be in AI at Penn Engineering, and what kind of students do you think would be graduating? I don't know the answer to this, so I think I'm going to ask you that question.
Well, no, you say, look, nor can I, but I would say that the students' fundamental learning of anything, so radio engineering, electromagnetics, radio signals, idea change. We understand a lot of things like massive MIMO, where we can manipulate signals, use the same frequency in the same cell site. 40 years ago, 2 PhDs, brothers came to my office and I threw them out of my office. I said, look, your ideas are great. I understand exactly what you're doing because I understand the science, but there is no digital signal processing in the world which can implement this. Okay? So 40 years later, every cell phone, every cell site, everybody is using massive MIMO. Everybody. Okay? Every phone has it. So I think what would happen to artificial intelligence, in my view, is certain things will happen. One is we don't know what would happen with quantum computing. But with or without quantum computing, I think what you will find is that engineers, as they learn this undergraduate degree, they will get smarter and smarter, and they say, how can we get out of the same computing power more? How can we reduce the computing power? How can we have more specialized, smaller models? We just don't know. Second thing for sure, we know that the onboard storage in the end of the network is already 1 to 2 terabytes. I'm not talking about the disk, just in today you can buy a smartphone with 1 terabyte, right? Well, if I had 8 terabyte, I can actually have not only the artificial intelligence, large language or small or micro model, we can actually have the data right there. For it, that it doesn't have to go to any source, it can have the data right there on your smartphone. So now everybody is carrying an artificial intelligence where you don't have to use the cloud. Of course, you can use cloud and hybrid model, but you are carrying an artificial intelligence machine right in your pocket, which can do all kinds of things. Perhaps it can actually answer all your calls, can think for you. I'm not saying it can talk to your mom, so your mom won't know that your machine is talking while you're doing something else. I'm not saying such.
It could be a bot.
It could be a bot. It could.
I have a better idea for that exact technology. Just at lunch today, I went over to Penn Medicine, and I was sitting with one of the senior faculty at Abramson Cancer Center, and we were talking about diagnostics and why family doctors don't have enough knowledge or intelligence or time to talk to their patients about what their cancer risks are. But what if they have this technology? While Raj was talking, what if they have this technology in their pocket and they say 3 words or 3 letters and they put it in, and suddenly they can then give advice to their clients, to their patients about what they should be testing for. They do a simple test, a simple blood test, even a 1-drop blood test. They say, well, by this, I'm telling you, you have a high risk for prostate cancer in 3 years, so I'm going to put you on this regimen. And suddenly you have this amazing ability to reduce the risk of cancer advancing. If that was a result of the pocket device that you just described, Raj, our big problem is we need more housing because everyone's going to live a hell of a lot longer. That would be really nice. So I think there's very distinct applications. Healthcare in America, which I think a lot about, is very disproportionately delivered because doctors are too busy. But if they had all the knowledge on a device in their hand and they could understand it, they can give service to their patients. Well, I don't even call them patients, but anyways, to the people in front of them that are using their services and help them to be more aware and possibly prevent cancer. And you have preventative medicines that are now being developed. On the back end of that, you can have great academic institutions like Penn, where engineering and Penn medicine collaborate, and suddenly we're finding many more discoveries much faster, so that when they find out what their possible diagnosis can be, they can immediately give them medicine to cure it.
You know, this is almost like the TV show Jeopardy. This is the answer to the question I was going to ask you. And the question I was going to ask you...
I bet $10,000.
You're ahead of me. The question I was going to ask you is, what is the future of Penn engineering? And you mentioned the intersection of research areas and development with Penn medicine. And sounds like this is one area where AI and medicine could come together very nicely.
And democratization of knowledge, which is essentially what Raj is talking about, and what Fred has been working on for a significant part of his career. The democratization of knowledge changes everything. Suddenly, people have the reliable information at their fingertips. If you give people a chance, you give professionals a chance to do that, suddenly it's more fair. Fairness increases.
And it has implications way beyond technology or standard of living or productivity to a society. It has to do with almost survival of democracy.
Yes.
So think about, you have knowledge and then you draw inferences. Now today we have been trained that inferences are drawn by some political psychos who tell us to think one way or the other. But if we had a proper way where the inferences can be drawn in a neutral, scientific, humane way, trustworthy way, well, opposite is also true. Then if you could do that, because knowledge and inference are both part of this AI thing, which is the beauty. And you can work in a synergistic fashion with humanity. I don't know where it goes, but I can tell you one thing, it's going somewhere.
It better go into the good guys' hands, because if what you describe is the bad guys' hands, we're all in big trouble.
I would say one of the big advantages of Penn engineering is that Penn has this multidiscipline approach to education, and Penn has been very on the forefront of that. So the Warren Center, which brings all those other disciplines to bear on engineering, is a good example of how the engineering school is now crossing over and working with the social sciences or with the law school or veterinary school, the medicine school. All of these things are made possible by this kind of interplay, which is required by those disciplines to have this underpinning. So that's why the future of Penn engineering, in my view, is extraordinary, because it's not just being a mechanical engineer or an electrical engineer, which is what it was when I came here. It's all these other aspects of engineering and technology and innovation in all these different walks of life that make Penn so well positioned for the future.
Certainly, I think the Warren Center is a center that was ahead of its time when it was founded. And I'm just amazed that it has connections to 5 different schools. If you count, Annenberg School of Communication, which you didn't include.
I forgot them.
Yeah, Annenberg School, Social Policy and Practice, the Law School, School of Arts and Sciences, and the Wharton Business School. So it's just a reminder that when we develop technologies, it can have so many different applications. And you're right, that is the future of Penn.
And Penn as a university is the right place for all that to come together, because that's where it's all happens.
Yep, and actually that's your persona. That's what Warren is.
Yeah,
that is true. So I often talk about the intersection, which is the physical intersection of 34th and Chestnut, because that's on one corner is the law school, is the Penn Carey Law School. On the other corner is Amy Gutmann Hall. but it's also the intersection of big data and thoughtfulness and humanity and ethics and caring and empathy and hopefully compassion. That's the real intersection. And we should think about
should work on the other corners as well.
Yeah, we have two more to buy. Well, one of them is the students. One of the corners is students. So the other one, we have some work to do. And it's not so far from the medical, the giant Penn medicine thing. So the intersection of all this thought is what we all dream of, I think. How do we bring these things together? What investments can we make? What can we do and it only can happen at a university. It can't happen in corporations. It can't happen in hospitals. It has to happen at a university.
So, well, they're going to keep arms around it. They want to keep, in fact, it's already happening. People want the control of their large language model. They don't want to share it. People want to do their secret things. I mean, it's already happening.
So how about one pithy sentence, or maybe even one pithy word about the future of this technology at Penn?
Okay, I would say, well, it's more than one word. Okay. So
sentence is fine.
Sentence fine.
And we're going to conclude after this, so make it your best sentence. No pressure.
So I would say that what we should teach Penn students is that they should take 1 hour of their day which is allocated to daydreaming. Daydreaming is very good because number 1 is free, number 2 is healthy, and number 3 is simply wonderful.
That's awesome. Good advice.
I will give you a very short sentence. Limited only by our imagination.
Terrific, terrific.
You stole my thunder. I would have said unlimited. Hey, upside. Of course, I'm an eternal optimist.
We share that pathology.
I get that.
Awesome. Thank you.
Welcome.
Thank you for joining us.
Thank you, Vijay.
And wonderful. Thank you, Vijay.
Thank you, BJ.
Thanks, Harlan. Hey.
You're the best.